On a summer afternoon in the year 1054, skywatchers in China recorded an impossibility. A second sun appeared in the afternoon sky, and as evening approached, it refused to set. Ancient astronomers painstakingly charted this anomaly, tracking a piercing dot of light that remained visible even under the high noon sun for nearly a month. This wasn't a star in the traditional sense. It was the terminal flash of a supernova, the catastrophic collapse of a massive sun happening 6,500 light-years away from Earth. NASA recently shared this image of the Crab Nebula. The sprawling web of glowing gas is the physical debris field of that 1054 explosion, continuing to expand long after its observers died. These photographs record active, violent evolution. They are frozen frames of a process unfolding on a billion-year timescale that we are only beginning to comprehend. Modern space telescopes function as light-shifting sensors. They translate invisible wavelengths into physical maps, exposing the mechanics of the universe that our eyes cannot naturally process. Saturn provides a clear demonstration of this shift. In the visible light spectrum, the range captured by the Hubble telescope, its rings and atmosphere appear familiar and relatively muted. Switching to the James Webb's infrared view reveals the planet's elemental composition. The rings glow with an intense brightness because their water ice reflect these specific wavelengths, creating a high-contrast map of the system's chemistry. This infrared capability allows us to peer through clouds of interstellar gas that would otherwise block our view, finding active nurseries like the Orion molecular cloud. Here, young stars act as engines, firing jets of superheated gas outward like rocket exhausts. When these jets collide with the cold outer dust, the impact creates the glowing shockwaves visible in these high-resolution captures. This violent birth contrasts with the quiet decay of the Eye Nebula. Instead of exploding, this star pulses, shedding its outer layers in concentric rings as its core slowly cools toward total darkness. Utilizing these different technological lenses allows humanity to observe the complete life cycle of celestial bodies that would remain invisible to the naked eye. Because cosmic structures are so massive, they appear completely still. A human lifespan is too short to watch an object 100,000 miles wide move across the sky. Astronomers found a way around this limitation in the Crab Nebula. By comparing photographs taken nearly 3 decades apart, they successfully tracked physical motion. This comparison between 1997 and 2026 captures the literal forward advancement of gas jets. We are watching the internal pressure of a nebula reshape itself in real time. While the Crab Nebula reveals the scale of time, the Westerland 2 star cluster reveals the scale of density. It functions as a chaotic gravitational war zone. To maintain stable planetary orbits, stars usually require immense separation. In our local solar neighborhood, the Sun has only about 14 neighbors in its immediate vicinity. This chart shows our neighborhood. Now, pack 3,000 active stars into that same volume of space. Westerland 2 is a graveyard of intersecting gravity wells and intense radiation, where a stable solar system is a physical impossibility. These deep space captures force us to look past our own experience. They reveal a universe of physical densities that make our solar system look like an empty exception. To find the final limit of scale, we have to pull back from individual star clusters and move into the structure of an entire galaxy. This is the Messier 101 pinwheel galaxy. Its shape was only fully mapped by combining Hubble's light data with James Webb's infrared sensors to see through the dust of its spiral arms. It spans 200,000 light-years in diameter. Within that disk, scientists have identified approximately 1 trillion individual stars. Messier 101 is twice the size of the Milky Way, offering trillions of additional orbital slots where rocky planets can form. This sheer volume of matter multiplies the statistical chances for stable solar systems to exist far beyond our own. If this single photograph contains 1 trillion stars and countless planets, it suggests that the billions of other galaxies hidden in the dark are teeming with similar activity. These NASA images serve as a biological census. They provide the evidence that the night sky is a crowded, active ecosystem, and we are just now opening our eyes to our place within it.